All right, here's number 7 of our in-class proof festival. I'm going to go ahead and start on the left side. And seems like, let's change everything to sine and cosine. I noticed that the denominator of both these are both sine x, or cosine x. That's sine x over cosine x, and that's 1 over cosine x. So I'm just going to go ahead and change them. So I've got sine x over cosine x minus 1 over cosine x. That's all squared. These already have a common denominator, so let's go ahead and put those together first. That's all squared. Well, let's just do this. Sine x minus 1 squared over cosine squared x. All right. So what can we do next, I guess? Let's see. Cosine squared is 1 minus sine squared. This is 1 plus sine x. It seems like maybe it's a good idea to do this. Yeah, 1 minus sine squared x is equal to cosine squared x. Alright, so that just seems like a good idea. And now, I'm going to go ahead and factor the bottom. Whoop. Uh-oh. I'm going to factor. I still have this. So I'm going to factor the bottom. This 1 minus sine x and 1 plus sine x. And the reason I'm doing that is that I see, keep your eye on the prize and see that, hey, I want a 1 plus sine x in that denominator, and it's right there. So let's think about sine x minus 1 and 1 minus sine x. How are those related? Well, if you look at it, sine x minus 1, the opposite of that is 1 minus sine x. So perhaps I can look at this up here of 1 minus sine x all squared, and then this is 1 minus sine x. This is 1 plus sine x. Okay? Now, when you square something, that opposite just goes away. Okay? So really what that amounts to is that sine x minus 1 quantity squared is the same as 1 minus sine x quantity squared, because this is going to go away. So I'm going to write it like that. Okay, that's going to give me 1 minus sine x quantity squared, so I'm just going to write it as 1 minus sine x, 1 minus sine x. Okay, now I have this on the top and the bottom, so that's going to divide out of there, and I'm left with 1 minus sine x over 1 plus sine x, and that is what I'm trying to prove. So that's equal to the right. And we are done.